Dear students, thank you for watching. I'm very sorry that I'm forced to stop our classes in the classroom in the university. I got sick and I have heard that not only me. So it is sad, but it is new reality. I wish everyone to quickly recover and I hope next Wednesday we will meet in the class. So, now we will have just a practice. I show you how to use QuickField. You already know very much about it. But now we will create together a new problem starting from the very beginning, and I show you how it works from the very beginning to the end, from idea to getting the results. Hope you will learn a lot from this lesson, from this short demonstration. Okay, let's go. What is our plan? First, we create a new QuickField problem and tune it. Then we open the QuickField model editor window and see how it works. Model editor, you know, it's responsible for geometry and mesh. You will see two modes. Model editor exists in one of two modes: selection mode or insertion mode. Next, we see how we use a grid to snap. It is auxiliary tool that is useful for easy drawing. Next, what geometry entities we will create and manage. Surprisingly, a few, only it can be a vertex or a straight segment or a circular arc and nothing more. Well, names. The concept of names, or we often say labels, concept of labels is very important concept in QuickField, because labels means names that we give to geometrical entity. We use labels to connect physical data with the element of geometry, and physical data includes material properties and boundary conditions and field sources. To applying that, we use names. I show you how. Then advanced features of model editor is move selected entities or duplicate. Move and copy. Copy and paste, our favorite section. Then we build a mesh and see how the mesh density affect on the solution accuracy. It's very important concept, and I will show you how it works. Then post-processing. We see the results, how we will see the field picture and how we can extract numerical data from the solution. How we control the field picture, extract local values, extract integrals, concept of the contour, and so on. And then we make our problem a bit more elaborate, just for fun. This is our plan. So let's go. Starting from create a new problem, there tune it, then save it. Now I finished to show you the slides and go to leave demonstration. My QuickField is here, it is empty, and I first create a new problem. File, new problem, or simply press this button, create new problem, or Ctrl N keyboard shortcut. Ctrl N. This is new problem creating wizard. Start from the name. Give a name to the new problem. My will be named Therma. Why Therma? Because today I want to show you not electrical, not magnetics, but heat transfer analysis, thermal analysis, because temperature field are more intuitive and less for understanding. Well, so starting from this, where to create it? I will create on drive D a folder named after me, D Simon. I recommend you to do the same in classroom. Folder names after you in the drive on the drive D. So name is ready, folder is ready. Press next. Tune our problem. This file, the PBM extension, thermo.pbm, only contains the basic information about our problem. What is the most basic information? First of all, type of analysis or formulation. We have a lot of electric formulations, magnetic formulations, but ours is, for today, it's steady state heat transfer. We have a choice between transient heat transfer and steady state heat transfer. Ours is steady state for today. Select. Then, no, it is just convenience. Length units, coordinate system. I choose millimeters for this problem. Our coordinate system will be Cartesian. Alternative is polar, but not now. And second important thing is model class. Ours is plane parallel, but let me show you model class in more details. Well. Okay. We have two model classes for two-dimensional analysis. They are plane parallel and axisymmetric. And also two model classes for 3D analysis, extrusion or import. And now we consider only the first two, plane parallel or axisymmetric. In two-dimensional analysis, we always draw our model in the modeling plane. It is our drawing is two-dimensional. We draw just a rectangle, for example, this rectangle. And how this rectangle is extended to three-dimensional world? We have two options. If our model class is plane parallel, our three-dimensional body generated from this rectangle is a block, is a box like this. And if we have axisymmetric model class, the same rectangle is extended as a hollow cylinder parallel to rotation axis, and the rotation axis in QuickField is hard-coded. It is always x-axis. Well, it is unlike, for example, COMSOL. COMSOL use vertical axis as the axis of rotation, but QuickField use horizontal axis, and it is hard-coded, only this and nothing more. Well, you see the difference between plane parallel and axisymmetric simulation. Let me show a few more examples. For example, you draw in your modeling plane three figures, three shapes. First is a circle, second is a semicircle, and this diameter has zero coordinates. It is coordinate axis. Well, and this is some rectangle. How they are extended in plane parallel case. Our circles becomes a cylinder. Our semicircle becomes a semi-cylinder. And our rectangle becomes a box. What is important? The size in out of plane direction, in this direction, is the same for all bodies. This parameter is not a part of geometry, it is a parameter of a problem. Let's see where it lives. If our problem is plane parallel, we have here a control for entering lengths in the direction out of plane. Well, it is by default 1 meter, but it can be set at any value we want. For example, now I'll set it for 50 millimeters. What's more, go back to our picture, and what happens if we opt axisymmetrical model? Our circle extruded as a torus, this one. Our semicircle, no, it is special semicircle near the coordinate axis. Semicircle because a sphere, a ball. And our rectangle is a hollow cylinder. Well, I think it is clear, it is more or less intuitive, but please take it in mind. Well, our problem is plane parallel and it has a length in out of plane direction as far as 50 millimeters. What's more, the problem itself refers to two auxiliary files. First of them, with extension mod, contains geometry and mesh. And second one, with extension D and problem and formulation types, HT stand for heat transfer. DHT contains physical data, material properties, boundary condition and field sources. Why so? Why we need three files in sake of reusing? Sometimes we reuse the same model for different simulation or so on. Maybe it is not the world best solution, but now it is so. Maybe sometimes we will keep everything in a single file, maybe. Well, our problem is ready. What we have said: formulation, class, length unit, coordinate system. Precision is always normal. We never need to change it to draft or high. Normal is okay for everything. Press finish. QuickField creates a problem for us and open for our convenience the geometry editor. Let's see. First of all, before we go further, let me show how QuickField user interface is organized. First of all, we see three windows: problem window, property window and model window. If you don't see the property window like this, if you don't see it, please go to the view menu, find properties command and switch it on, and your property window appears back. Well, if it is located in wrong place, no, for example, I don't know where, here or maybe or maybe another position, just drag it to desired position, and canonical position is here below the problem, and divide it more or less the same size. Well, again, problem window, property window, model editor. Next, this is model window, and I want to show you how the main menu differs according to what problem is active now. Let's click on the problem window, this one. You see it is now active. Sometimes in some system you can see it by color of your caption, but it is not common. It depends upon your Windows settings. In my Windows I see the selected window because it caption differs. Anyway, this is a current window, current or active window. How the main menu looks like. The file menu is more or less stable, but not exactly. Edit menu is very short. View menu is extremely short. Well, they only contains command that applicable to the problem itself. Then I click to the model window. It is now current window, but no visual feedback. No, it is not ours. It is Windows settings. Let's visit our main menu again. File menu has an additional command. This one, import DXF, import from cat, if we need it. But let's see our edit menu. Our edit menu is long and contains a lot of command. The command applicable to editing geometry. Let's see our view menu. View menu is also very long, much longer than it was before. And the settings, view settings, applicable to the model window settings. Is it clear? You should understand that contents of your main menu depends on which window is active in this time. If you lost some command, you know that it should be, but you don't see it. It means that wrong window is active in this time. Activate another window and you see your command. Well, now we will build our model. We will draw here. Our model will be in size at 50 by 50 millimeters. And what is current size of our window? Let's see this area. This area below my face. It shows the coordinates of cursor. Now it is -1 meter, +1 meter. It is default. Approximately 2 meters by 2 meters is our window. It is good idea to zoom in to the small size, 50 to 50 millimeters, something like this. Well, now -100 +100, more or less okay. Well, now what we see now, there is no model, no geometry, just auxiliary lines. This is coordinate system, this is the origin, and some grid to snap. What is the step of this grid? We can control it. Right click by your mouse grid settings command and see that our grid settings is 5 millimeters. Our grid is 5 millimeters. Let's set 10. 10. Press OK. So now I just quickly build a rectangle. I will explain you later how to do that. Now I will just build something like this. My simply rectangle. I built it, go back and see my rectangle. Well, now I will zoom in and zoom out, and please watch how visually changes the size of my shape and cell size. I do first zoom in. You see that my shape gets bigger and bigger, and cell size remains more or less the same. Why so? This is because of settings of my grid. Change, let's watch again grid settings. There is a flag scale with zoom or don't scale. If I refuse to scale, my grid will always 10 millimeters, not the pencil size. Let's see how it looks like. Now the size of my, not visual size, but actual size in millimeters remains the same, not depends on zoom in or zoom out level. Well, sometimes is useful scale grid, sometimes is useful not to scale. Now I think it's better not to scale, and I leave this flag off. Let's see again my flag, where it is. Grid settings, not to scale my grid with zoom. Sometimes it is more convenient. Well, select everything and delete. Now I press delete button on my keyboard, everything will be deleted. Well, now about model editor modes. It always exists in one of two modes, either select mode or insert mode, and those two buttons are a switch. Select mode, it is default mode. In the select mode, our cursor is arrow shaped. We can pan by pressing left mouse button, drag with left mouse button pressed, and we can point and select some shapes. Well, when we switch to the insert mode, you can switch by these two buttons, or another way is using keyboard shortcut. Keyboard shortcut is insert key. Now I just press several times my insert key. Oh, see, it's here, not here. This one. Insert key, switch between two modes. Well, now I am in insert mode. This mode is intended for drawing. I can draw a line, or draw an, for example, draw an to say arc like this. or something like that. Well, undo. Ctrl Z makes for me undo. What we see in this inserting mode? We see not only a single cursor, my cursor is now cross-shaped. I also see a red marker. My cursor moves smoothly. My red marker jumps. It jumps according to the grid. And you probably understand that if I create something, it will be created in a position shown by red marker. Well, okay, let's create something. Let's create a point, a vertex here in coordinates -20 and 30, like this. I put my red marker in desired position and double click. I double click and my vertex is created. So don't confuse vertex with red marker. Red marker still jumps, but this geometrical shape, a vertex, still exists in this place. Create another one here. Create, it is created. And now I connect it by dragging. I connect them by dragging, but my central angle should be 0. Connect, and I create 2 vertices and 1 edge, 1 straight edge. How I do that? I did it by dragging by left mouse button pressed. It is necessary to connect by an edge to existing vertices. Absolutely not. I can create an edge in a free space. For example, simply drag from starting point to the ending point, like this. And now I will create 2 vertical edges, this one and this one, and go back to the pointing mode or selecting mode. What happens? I see there are edges. I have 4 edges, 4 vertices, and 1 polygon. We call it block, 1 block. Let's see the summary of our geometry. We have 1 block. How much edges? 4 edges and 4 vertices. Well, how we create this block? Fully automatically. We create only edges, and the block created automatically. Well, and now I create a new edge. From example, starting here and ending somewhere here. And let's see what happens. To create something, I switch to insert mode and drag. Like this. Let's see what happens when I release my mouse button. I release it. And what is created now? I create only 1 segment from this point up to this point. But actually I create 1, 2, 3, 4 vertices. How many edges? 1, 2, 3 edges. And this is not a full story. I also has automatically create 2 blocks, upper and lower. Everything happens absolutely automatically. Well, so it is QuickField. Welcome to our software. So now I want to show you how to select. Now I am in selecting mode. When I move my mouse, the objects, the entities on the mouse highlighted. Highlighting is temporary. This edge is now highlighted. When I go out, it's lost highlighting. Now instead a polygon, a block is highlighted. Now this block is highlighted and now this edge is highlighted. A vertex also can be highlighted. Highlighting is temporary, but if I click to the highlighted object, for example, to this, click, it is now selected. Selection is permanent. No, it's permanent until I select something else. When I click again, for example here, another edge is selected. What if I want to select several objects in the same time? I keep my Ctrl button pressed, and now I can multiple select. Do multiple select. Well, I can select edges, I can select vertices if I need, and I can also select blocks. I click and it is selected. And this one is not selected, it is highlighted. But if I click in the highlighted object, it gets selected. Clear? It's easy. To select everything, I can use this keyboard shortcut. Select all, Ctrl A. Unselect all, Ctrl D. Or instead of Ctrl D, I can click anyway outside of selection and everything will be unselected. So Ctrl A, Ctrl D, Ctrl A, Ctrl D. Okay, now you know how to draw, how to select. Let's create our first shape. Undo several times to delete unnecessary things. Unnecessary is this group of edges. No, selection is also what. Oh, now good. Now good, it is our starting point. So, next exercise. I need a vertex somewhere here between the cell inside a cell, not in a grid vertex. How to do that? No, at least two options I have. Either makes my grid size less, or create numerically by entering coordinates. I will show you the second way. I go to the edit menu, insert add vertices command, and the dialog appears for entering coordinates. I need +5, -5. 5 -5 and press enter. I expect a new vertex created somewhere here. Add, and it is created. And second one somewhere here, 15, 15. 15, 15. Add, and my new pair of vertices is created. Now I want to connect it with an edge. Just connect. To connect, I first go from selecting mode to inserting mode. Next, go back to selecting mode and select newly created edge. Now I want to mirror it. mirror with respect to vertical axis. It is easy. Let's see how to do that. Go to the edit menu, choose the duplicate selection command. Duplicate means copy, because the word copy is already occupied for to copy to clipboard. So duplicate geometry. QuickField can duplicate by displacement, by rotation, by symmetry. We need a symmetry now. Symmetry, axis of the symmetry is given by a point and direction. Any point and the direction angle. Origin is a good point because we need to describe this axis. It contains 0 point, so only angle, and the angle is 90. Angles in QuickField always given in degrees. So I expect my new edge to be created somewhere here. Let's see. Press OK. OK, it is selected. It is created. It is created and gets selected automatically. Now I want to connect this and this point with a circular arc. It is easy. It can be made the same way as we build segments, but first we set central angle. Central angle we can select from the list or type our own central angle. Let's first select 90 degrees arc, go to insert mode and drag from beginning to end. Please pay attention with our red marker snaps not only to grid cell but also to the existing geometry, here or here or here. Well, we create an edge. It is 90 degrees and I want in this context 120 degrees. So Ctrl Z to delete it, change the angle, 120, press enter. This degree symbol shows that our angle is accepted by system, and build my arc. And here I want to arc with central angle more than half circle. My central angle will be 270 to 270, like this. Okay, go back and I create two blocks, this and this. So my geometry is ready. Geometry is ready. What to do further? Name it. Name the geometry entities. Which one? Each block and edges where the boundary condition are given, should be given. Well, each block should be named except of holes. Let me show how it works. Now, for example, this block is I selected. First I select, no, again. I move my mouse, my blocks get highlighted. When I click to the highlighted, it gets selected. And I give name to the selection. What will be the name? Any name, not longer than 16 characters. For example, name will be plastic. and press enter. When I press enter, new name appears in the problem window under the block labels branch. So it is a part of our problem. And I want to use to left this as a whole. It will be not a named block. I don't want to calculate field here because not don't know because what. It is a hollow. The field will be not calculation here, not calculated here. Well, what about boundary conditions? Let's set this, consider this edge as a cold side and this one as a hot side. I set the boundary condition, some suitable boundary condition to set to QuickField. This is hot place, this is cold place. To set any boundary condition, I need to name an edge. This edge and this edge. To name something, I first select by click and type its name. Name will be cold and press enter. And the newly created name appears in the problem tree. Highlight, select and give a name to the selection. Name will be hot. Press enter and the second name of second edge label appears here in the tree. Now give the properties. What kind of properties? For example, plastic. I need now to I would like now to give some properties to it. To do that, I select the label in the tree and double click on it. After double clicking, the label properties dialog appears, and we see that QuickField wants us to enter here the thermal conductivity of the block. What is the thermal conductivity of a plastic? No, I think some 0.4 in C Unix. It's more or less similar to polyethylene or something like this, some plastic. It's enough. For transient problem, we need also specific heat and specific density, but it is only needed for transient analysis, and for static analysis we need thermal conductivity and nothing more. So press OK, and please see that our plastic label is now marked by question mark. Question mark means there is no data. When I press OK, the question marks disappears. Well, this label is fully defined. Now, what is the give boundary condition? Hot and cold. Starting from the cold side, double click and see the list of boundary condition. Possible boundary condition list includes given temperature, given heat flux, given convection or radiation. We start from the simplest. Given temperature is a boundary condition of the first kind, or directly a boundary condition so kind. We choose it, opt it, and set the value. What is cold? No, for example, room temperature 20 Celsius degrees. Press OK, and our boundary condition on the cold side is fully defined. Do the same on the hot side. opt the same kind of boundary condition, isothermal boundary condition, which means given known in advance temperature. And the temperature will be higher, for example, 60 degrees. 20 here, 60 here. Press OK. Our problem is fully defined in terms of data. It's good time to save everything. Save. And try to solve. Can we solve? I think not, but let's try. Try to solve the problem. Ctrl L shortcut or this green equal symbol on the toolbar. Press it and let's see what happens. Aha. QuickField says no mesh. We forgot to build a finite element mesh. Okay. Let's do that. To build a initial quality mesh, default mesh, we simply press the build mesh button. But before doing this, please always save your work, because building mesh is in some way dangerous operation, and there is a risk to lost everything, lost your work. So kindly ask you, before pressing this button, press this one. Okay, press the build mesh button and the mesh is ready. Initial quality, but good for the starting point. Where the mesh is built? Only in the named area. This area is named, name is plastic. This area is unnamed. Unnamed is still unmeshed. It is normal behavior. Well, let's try to solve our problem again. It asks for saving. And the problem is already solved. It takes only 5 seconds to solve it. Well, let's see. It works very slow because of recording. With no recording, I'm sorry, it's my son. I'm sorry. Well, and this is our solution. Field solution. Field pictures on. We can even close our model window, close it, and only see the field solution. How it works? It shows field picture by different method. It shows color map. Color map can be switched off and on. Fill lines. In this context, isotherms. Also we can switch on and off. And unit. Step between isotherms is now 2 degrees. let's change to 1 and press enter, and you see what happens. We can change the number of colors grade. For example, 20, it is rough, or maybe 200s, it is smooth, or so on. Well, what's more, how to extract local data. Local data means field values in given point. For example, we want to measure our temperature somewhere here. We go to the local values tab. Our cursor is now a probe, and just click here and see with the temperature here is how much. The temperature is about 20. No, 20 is boundary condition here. Here is a bit more than 20. For example, if we need to know the value in exact point, we can edit its coordinates. For example, 0, minus 18 millimeters, and press enter. My cursor goes to the given point, and I can read the value 20.16 and so on degrees. Well, in this point, how much? No, something close to 60. Let's see. Yes, very close to 60. And what happens in this point? It is green, so somewhere about 40. Let's check. This about 40. Well, well, what else? The probe point is shown by a mark you see here. Coordinates of probing point is shown here. Maybe let's enter it exactly, minus 60, 10. So our cursor goes to this point, and the temperature value is about 40. Well, what about integral quantities? Oh, okay, integral later. Is this picture realistic or not? Is it good or not? No, probably yes, probably it looks good. But what happens if you see the details? If we see small details, we see that the fill lines, our isotherms, looks not good. They looks not good. They are not smooth enough. Why so? What is the reason? Why our lines are not smooth and what happens? How to control? Sorry. I want to control the step between is lines. It is now 0.17 and I want 0.1. So what I see is more it's better to see without coloring. My fill lines looks not good. Why? What is the reason? You probably understand what is the reason. The reason is with our mesh is too sparse. Mesh is not dense enough. How to deal with a mesh? We have two options, and we will learn them in details later. But now I want to organize my window vertically, like this. Geometry and mesh. Geometry and mesh is here, and field picture is here. To zoom in, Now it's zoomed in. I want to zoom out, zoom to fit, for example, like this. Switch different type of presentation on and off. I can also show you the vectors of flux density. Vectors is here. I can control the density of vectors, for example, like this. Make it more vectors, even more. Make them longer. And so on. They show how the thermal flux is going on my model. Well, switch off vectors. Now I want to make my mesh a bit denser. How to do that? Manually or automatically? Starting from the simple, starting from automatic way. This button is to solve, and this button is solve and refine. Solve and refine means iteratively make our mesh denser and denser. Now let's do only one iteration. No, okay, two. And let's see what happens. Let's watch on this picture. And when I press OK, watch on this. My mesh gets denser automatically, and then even denser. Solution is ready. Where is my solution? Okay, the solution is now loading. My computer works very slow when it is busy with recording. Okay, organize. No, better to make it automatically. Organize my windows in such a way that they occupy full place of screen. Well, this picture gives more realistic values. And secondly, I want to show you how to extract integral data, not only local in given point. Close the geometry and concentrate on the field picture. The concept of contour. To integrate something, I need to define domain of integration. Domain of integration can be a line, a surface, or a volume. To calculate heat flux, I need to define a surface. Surface in 3D sense. In two-dimensional picture, it is not a surface, it is a line. Line that is a trace of our surface. I create, for example, I switch off the color map to better visibility and create some line like this. this is a line, can be used for integration and it can be used for plotting. Starting from plotting, the field plot shows the field, in this case the temperature distribution along the line. Let's wait for a while and see the field distribution along this contour. So somewhere is a maximum, there is less, there is more. Okay. And the same contour can be used not only for plotting, it can be used for integrating. For example, we integrate heat flux over the contour. To do that, if we already have the contour, we go to the integrator, it lives here, integrator, or you can use for navigation this button, field settings, local values, integral values. The same as here, field settings, local values, integral value. And we see the value of heat flux. Heat flux is 0.3 watt totally. Okay, and now I switch off the contour editing mode, and now I can modify this contour by dragging like this. Let's see that our heat flux does not change significantly because the whole flux concentrate here. It should not depend on the position of our contour at all. It depends, but not a lot. This depending is only due to numerical error. And this is the value of heat flux. Well, and now the latest exercise for today. Let's change our boundary condition. Go back to the model. And see where that our boundary condition are now made to, now they are too simple, not very realistic. The more realistic boundary condition can be not isotherm, but with convection. For example, our cold side in reality probably have not given temperature of 20 degrees, but it is a subject for convection. Convection by ambient temperature of air, for example, 20 degrees, but the convection coefficient should be get from some heat transfer textbook. No, in the room it should be somewhere about 5 to 8 normally. Set 5. Well, and our hot surface, this one, is our subject for convection. It has ambient temperature as 60 as it was before. Ambient temperature 60, but the convection coefficient a bit bigger than here. Here we have 5 and here we set a bigger, for example 8. Press OK and calculate again. The problem is changed. It should be solved again. The solution time is relatively quickly, a few seconds. And now our post-processor starts to load. In normal situation it makes it be much quicker. Well, let's wait. Okay. I have no idea why so slow. I think because recording. Switch, close our model window and see the temperature range. You remember it was exactly between 60 and 20. And now the range is less. It is because 32 up to 54. And this field distribution seems to be more realistic, with different boundary condition. So, it was a short demonstration of ability, and I think you are now more or less experienced user of QuickField and you can solve simple problem. And next time a week late, next week we will have a long seminar and we will start with electrostatic simulation. Okay? Hope to see you in well condition. Hope to see you all next time. Thank you for watching and goodbye.